About half a year ago, I started a thesis-based master's program in computer science, specifically with an interest in artificial intelligence and machine learning. And I did so because I not only have a deep interest in the field, but just love the idea of doing research in AI and pushing the boundaries of not only what we know, but how we can use artificial intelligence. And while the past year for me has been incredibly exciting, it's also been quite challenging. And throughout this time, I've been sharing lots of the things I've personally been learning with all of you through this channel I've had, and that has been an absolutely incredible experience. But I do feel like there's still a lot missing from what I'm showing you on this channel. My goal from the very beginning with this channel was to teach people about, AI and ML, but beyond just that, it was to hopefully inspire people the same way that when I saw AI when I was in high school, I was inspired and was just absolutely struck with awe by what we could already do with AI and ML. When on this channel, I go over a paper and talk about my opinions on it, or maybe we go over some code, that's neat, and don't get me wrong, I plan to keep doing that, but I'm still leaving out so much of what research is actually about. You're missing out on the days or sometimes even weeks that lead me thinking about an idea that ends up leading to a paper that I end up talking about on this channel. You're also missing out what I probably spend the majority of my time doing, just trying to come up with ideas, then run experiments to test them, sometimes failing, but sometimes also getting really neat results that make you really excited. And heck, you're even missing out on the nights I spend with friends, drinking and talking about how we might get to artificial general intelligence, or whether or not it's even possible to upload your consciousness to a computer. So I'm making this video because I want to show all of you, all of my viewers, what it's really like doing all of this. A peek into the journey of it. And I want to do that because if I share all of this, I think that maybe, just maybe, you'll get the same sense of wonder that I do constantly working in this field. So yes, this is a new series I'm starting where I'm hoping to share my journey with you, specifically focusing on what I'm doing behind the scenes in terms of research. And just a quick note to any of my longtime viewers, yes, this is actually taking over the old Zero to Paper series. Unfortunately, I did not have enough time to continue that series, but I think this should be very similar in spirit and hopefully even more interesting. And just something I want to be completely clear about, this isn't supposed to be me telling you how to do good research or what you should be doing or this is exactly what this is like, because I'm new to this myself and I'm still figuring the whole thing out. Heck, that's kind of the point of it. For the rest of the video, I first want to dive into my notebook, which is where I've actually been writing down a lot of my ideas as I've been trying to come up with ideas for a thesis. And after that, we'll jump into a little bit of code that I've been writing to implement some of these ideas so I can run a few experiments, test them, and see how they actually play out. The last thing I'll mention before we get to it is if you like this sort of thing, do consider liking the video and subscribing. It really does mean a lot. Anyway, without further ado, let's get into it. So here we are in my notebook, and you can actually see here that this was just something I was working on the other day, but this is me sort of trying to draft out my idea I had for my research here. I've often found that if you draw a bit of a diagram or some notes, it can really help later when you go and implement this in code because there can often be so many moving parts, it's easy to get lost. So you can see not only was I drawing a diagram, but also trying to write out sort of sub-equations for this. I've been really bad at formalizing my ideas in the past, so I thought it might be a good idea. I'm sure this looks like a lot of gibberish to you right now, so let me sort of turn a page here. I have another page here. Let me try and explain the core of my idea and what I want to do in this research. I think that's a fitting topic for a first episode. So the general idea is that we're working within the domain of reinforcement learning, right? So to make sure that everyone has an understanding of what that is, it's essentially where you're in some environment. So it could be the real world or it could be a chess game, that sort of thing, right? And you want to maximize some reward. So in chess, your reward might be to win. So winning a game is often a big reward signal people give, but it can also be other things, right? We can have intrinsic rewards, intrinsic motivation to explore and do other things. But that's the general sort of paradigm we're working in. So within this paradigm of reinforcement learning, there's a lot of interesting subproblems. The one I'm particularly interested in right now is representation learning. And the idea of representation learning is that we want to learn some sort of representation, as you might have guessed, that's useful for whatever task we might want to do. So for example, if I'm, a human in the real world, as I am, hello, thinking of the world in terms of the individual small pixels my colors of eyes might see, it isn't really helpful. Like if I say, oh, there's I guess I don't think in or I don't have pixels exactly, but if I say, oh, there's a blue light directly in front of me, and then directly next to that, it looks slightly redder, that's not nearly as useful as saying, for example, oh, that's a car in front of me and it's going very fast and it's about to hit me. That's a much more useful representation of the world, right? So the idea with representation learning is that we want to learn some sort of representation so that when we're trying to learn some task, and we're probably going to want to learn lots of things, right? We want to have some representation that helps us learn all of those faster so we don't have to relearn all these elementary things again. So one question we really want to think about when we're talking about representation learning, and this is a very key one, is what makes a good representation? And if we want to first sort of mathematically try and define this, well, a good representation is one that's going to maximize some reward function, right? We're going to maximize some reward function by changing maybe, I don't know what we want to call this. We could call it like phi or something. It doesn't really matter. But we want to maximize the reward. The issue is that lots of times when we're doing this, we don't know what the downstream reward is. Oftentimes we're, as a baby, right? We don't have any, maybe we do. I don't remember what I was doing when I was a baby, but in general, right? Babies just kind of flail around. They don't really have very targeted actions most of the time. They don't have long-term goals, yet they're still learning how to control their body, right? And they that's, I guess, something humans probably intuitively know, that learning to control our body, it's like an innate thing we learn to do because it's very important for later in life. So then the follow-up question to this is, what type of objective will maximize this reward? Or how do we learn a representation that will maximize this? And so it can be helpful to think of this in terms of objectives. So say we have a function that maps an observation to, I guess, what we call a belief state. A belief state generally just means, I'm pretty sure it just means what we believe the total state of the world to be, right? So if I'm doing peekaboo with a person, my observation might just be their hands, right? So I just see their hands as the observation. But my belief state would, as long as I'm a normal adult, would be that the person is still there. They haven't disappeared. They're just hiding behind their hands. Whereas for a baby, right, they don't necessarily have this when they're first born. That's why peekaboo is so interesting. They don't have object permanence. So how do we construct a good belief state? What objective might be helpful for that? And what I want to work towards, and this is not original in any sense, but I do think it's an idea that hasn't been explored enough, is the idea of predicting the future. Lots of people have suggested this. There's been lots of papers about this, and there's also been literature in the neuro area that talk about how the brain does lots of predictions, and one of the ways we actually learn is when something is not as we predicted it, well, we update our synaptic connections, and that helps us learn. One thing that's also interesting about predicting the future, though, is that you can actually prove that if you have some observation, right, and you predict all future states. Well, as it turns out, and this was something I was trying to figure out the other day, but it's actually fairly simple to prove that if you have some observation, and from that observation, you can predict everything that's going to happen in the future, and you know what the reward function is, so you know what your goal is, right? Well, you can actually perfectly maximize that reward function. You can perfectly do the goal. And that's why I think predicting the future should be such an important part of learning representations. So that's easy enough to say, right? But when we actually implement this, there's all sorts of different ways we can implement this. And some of those work pretty well and some of them don't work very well. So what I sort of want to do with my research is figure out what ways do work well, why do they work well, and how can we get the best mileage out of this idea. So the way I'm structuring my project right now is we want to have two parts. We want to have an exploration part, and I'll explain why this is important in a second. And we want to have I'll just say representation learning part. These are both very important because without exploration, well, if you're always looking at the same thing in your environment, it's probably going to be very hard to tell what's important if, again, you're always just looking at the same thing, right? If you only ever saw one state of the chessboard and you couldn't consider any other ones, well, no matter what there's no good representation you can learn from that, right? So for exploration, I'm kind of still debating what I want to do, but for representation learning, sort of going off what we were talking about like up here, I just want to try predicting the future. So I want to try predicting a couple things. One is the next state. So if we can predict exactly what's going to happen a step after this has been done a lot. So it's fairly well known how this works, but I want to make sure I have a working baseline. But then I also want to try and predict, well, here's the thing, I kind of want to predict all future states, but there's always a variable amount of future states. It could be a lot. It's kind of hard to work with that. So we can predict random next state. So not the next state, but maybe the next state, or so on. And then the last thing I want to try and predict are the successor features. And this has also been done. The idea behind successor features is essentially it's a combination of all the future states into one representation. If we can view each state as a vector or like a list of numbers, right, which we should be able to in most cases, Well, then the successor features are essentially a sum of all the future states. If we sum them together and we discount, or we essentially make the ones further in the future less important. So the ones more immediate are more important in that summation, and the ones further in the future are less important. The details here aren't super important because we can get into this later, but that's sort of the general idea. So just to draw, maybe actually this will make more sense now if we go back to the diagram I had earlier. So if we look right here, we start off with an observation, and then we go through a latent encoder, is what I'm calling it. But really, it's just this produces our belief state, which would be Z. And we also take into account the last latent state, right? And that's because time is very important here. The example of peekaboo, right? If we never saw the person going behind the hands, we might not know that the person's there. Maybe that's a poor example because if there's hands there, there's probably a person there. But you get the point, right? Like if a person walks behind a car, if we never saw them walk behind the car, well, how are we supposed to know that there's a person behind the car? So then this is predicting the successor features, right? So we have another network here going from the belief state to the successor features prediction. And then we also want to give it the policy parameters. This essentially means we want to tell it how we're deciding to make actions, because we can't predict the future unless we know what our behavior is going to be like. If our behavior is completely random, well, we're probably not going to be able to predict the future very well. But if we know exactly what we're going to do for every situation, well, this is going to be a lot easier. Now that I've sort of taken you through this, though, I do want to head over to the computer where we will try and implement this. I've already gotten a good start, but there's still a bit to do, so I'll go ahead and show you what I have there. Here you can see we have the code pulled up. Instead of going like line by line through this, or even through lots of it, I just want to give a brief overview. And I can start out by sort of showing you this GitHub repository. On this repository, I've kind of set out a number of goals for myself. So here you can see some of the objectives I want to code for representation learning. We have things like predicting the next state and predicting the successor features, things I just talked about. Then we also have different exploration methods. So things like surprisal-based exploration, entropy-based exploration. So surprisal-based, right? That's where the more surprised you are by what you see, well, that gives you essentially a reward. That means you want to explore that area because you don't have a good model of it yet. Whereas entropy-based essentially means you want to explore areas that are not very explored yet. I guess, obviously, right? But it's the mathematic formulation has to do with entropy. It's why it's called entropy-based exploration. We also have an array of environments that we want to test out on. Grid World is like a very classic one, but we also want some harder things like Atari, and also maybe something like the DM Control Suite, which is where you have like, it's not robotics, but it's like you have these creatures trying to walk around and do things. When you're running experiments, it's always important to have a good range of experiments instead of working with one environment, which can be very biased. And then we also have a few different models that we want to use for essentially testing whether or not our representations are good. Because once we've learned a representation, we need to make sure that's a good representation. And I think the best way of doing that is just using it and seeing how it works along with another algorithm. So Rainbow and proximal policy optimization are two very popular ones. Maybe depending on what environment we use, we might use one or the other, and a few other things. And then there's a few other parameters, like whether or not we freeze the weights of the representation, right? Should we allow the model to change how our representations are generated? Maybe that's good or bad. And how we also transfer, which I won't go into too much right now. I want to save this for a later video. But now that you see like the sort of how this is broken up, basically we have the representation learning methods, the exploration methods, and then we have the downstream task models or methods. Now that you see that, you can kind of look in here and see that's reflected here, right? We have the agents, and within agents we have representation learning methods. So here's like the next state predictor or the successor feature predictor, sort of what I was talking about. Then we plug that into an exploration. So here we have things like the Easy Explorer agent, the Surprisal agent, and then finally we have like PPO and Rainbow, which are the task agents that I was talking about. It's split up in this way so that we can run experiments using any combination of these. So let me show you an example of what I'm talking about. If we want to run this, we can just type Python run experiment, and then we can specify the environment. So the environment might be something like mountain par v0. This is a very common environment when you want to test exploration. This is essentially, I can show a picture right here. Let's Google it. Here we are. And essentially what's happening here is you can see this little car right here. It wants to get to the top of this hill, and it can either go left or right each step. The issue is that, you can't just go straight up the hill. It doesn't have that power. So first it has to go to the left and then the right and then the left and sort of gain momentum until it can get up to this. And this is actually, the chance of doing this by random is very small, and that's why it's an interesting environment to test when it comes to exploration and representation learning algorithms. Maybe representation learning not so much so, because it is fairly simple, but even in these types of environments, you can still do some proofs of concept at least. So we specified the environment. Next, we can go ahead and specify, let's specify the representation learner. So rep learner, we can say the successor feature predictor. And to see sort of a full everything we have, we can come down to experiments over here, click on register. So here you can see all the representation learning types are registered, same for exploration agents and same for task agents. So next we need an exploration agent. So we can specify that to be something like surprisal. And then finally, we can specify the task agent. So the task agent is going to be, say, PPL. Now, if we run this, we should hopefully get something. Yeah, okay. So you can see we have weights and biases booting up. This is for logging. I'll show you that in a second. And here we go. So let's give this 1 second. I'll be right back and we'll see if this works. Okay, now we're back. And if you ignore all the different warnings up here, you can see that it's printing out as we go. So we're currently on step 15,000 and it prints out the reward it gets, the losses of the different models, the loss of the representation learner, and all this sort of thing. And what's really cool is if we pull up weights and biases, we have this sort of integrated. This is not a sponsored video, by the way. These are actually previous runs, but this will update live. It looks like it's a little bit delayed right now, but generally it will update live and we'll be able to see things like the representation learning loss, the exploration reward, all these sorts of things. These are only over a few steps, but generally we'll be able to see these over a much longer time span, which is pretty cool. It helps not only to see the experiments, but to organize them and that sort of thing. So that's essentially what I have right now. This really is just the beginning though. Now that I have lots of this implemented, I still do have a few more things that I need to implement, but I want to start doing some testing, right? And to test, we have lots of different combinations we can do here. So I'm going to have to get this running on like a large compute cluster, which is going to be interesting. We'll then have a huge array of experiments. Hopefully I'll be able to show in a follow-up video to this if people are interested. And that's, that's still not enough. Once we do this testing, we still need to come up with an original idea for this research. This is still, really just a survey of different methods and seeing how they perform to give myself an idea to better inform my direction. But once we do have that idea, we're going to have to come up, or rather, I'm going to have to come up with something. So hopefully I will have some more ideas, some more interesting ideas to talk about in the next episode of this. Hey, we're back to the present, and I hope you all enjoyed that little peek into what I've been doing. If you found that interesting, or maybe you actually didn't find it interesting, but you thought I could make some changes that would make this a lot better, please do let me know in the comments. I really want to do this whole idea of taking you all along with me on the journey through grad school, but I'm not exactly sure what the best way to do that is, whether or not you want to see my notes, see what I've been coding, see what papers I've been looking at, do more of a vlog style thing. I don't know what's going to work, so let me know in the comments. I'd be very curious to hear. Anyway, this is not a one-up video, so there will be another one. Thank you so much for watching this time, and I hope to catch you next time.